Good day, welcome back to the Math Salon. I'm Dr. Mendel. So we'll continue to look at problems in the topic of combination and permutations. So these are three model questions, and we always try to make sure we take our questions from standard examination boards. That can be the GC, that can be WAEC, that can be SAT, that can be even matriculation boards. So in this case, what we do, we are going to look at three examples here. The first one says, find the number of selections of 3 students from a class of 7 students in which the class prefect must be included. So here our n, small n, 7, and r is 3. So we have to choose 3 from 7. The key word here is selection. So this has to do with combination. So 3 students have to be selected from 7, but there's a special condition here. Special conditions must always be taken into account and given priority. The prefect must be there. So first I have to select the prefect. There's only one prefect in the class. So I'm going to choose from that one prefect. I will choose one. And you have to choose one prefect and 2 others. The and is considered here as a multiplication. If we use or, it's a sum. So one prefect is chosen from one prefect, and I have to take the prefect out. So the remaining number of students are 6, and from them I need 3. I already chose 1, then I have to choose 2. So that's simply here, 1 combination 1 is 1, multiplied by 6 combination 2. And this is 1 multiplied by 6 factorial, divided by 6 minus 2. That's 4 factorial, 2 factorial. And that is 6 times 5 times 4 factorial divided by 4 factorial, 2 factorial. 4 factorial goes off, 2 factorial is 2. 2 here, 3 times 5 is 15. So it means there are 15 number of possible selections that we can make of 3 students from a class of 7 students if the prefect must be among. Second question, it says, find the number of arrangements of the letters of the word minimum. We already saw in the past that when we have to arrange letters of a word and all letters have to be used, then we use our idea of permutation, and we go to look at factorial notation. In this case, there are 1, 2, 3, 4, 5, 6, 7. 7 factorial number of arrangements that can be made here from this. There are 7 of them. 7 factorial of them. However, the letters of the words that repeat makes that we have exaggerated our count. Because I have 3 M's here, when the M's change position because they're identical, it would be the same arrangement. So we have to reduce our count. So since M appears 1, 2, 3 times, we reduce by 3 factorial times, because we already learned that 3 letters can be permuted 3 factorial number of ways. So in that case, if the M's change several times, we'll be counting them as new. Minimum can then be written minimum in 6 different ways, and you will not know the difference because M's are exactly the same. And there are also 2 I's here, so when the I swap position, you won't make a difference as well. So we'll reduce that. So the number of ways of arranging the letters of the word minimum is then equal to 7 factorial divided by 3 factorial, 2 factorial. Let's go to a third question, which is much more interesting. You should note that the counting that we did, permutation and combination, are also going to help us when we finally come to probability. We will need to know our number of counts in the general situation and in the particular chance situation. So let's go to question number 3. A bag contains 2 green balls and 8 of different colors. Find the number of different selections of 2 balls that can be made from the bag if all balls have the same size. So if that is the case, what we see here is contains 2 green, 8. So my n is 10. So there are 10 balls in total. We have to make something, select 2. So my r is 2. And there's a selection. So selection here tells you that it has to do with combination. Previously was arrangement. That's how we look at permutations. See, so this is selection. Here, a special condition is there. 2 of the 10 balls are green and of the same sizes. So it means that there's no way you can make a difference between these 2 balls, and we have to really be careful. If we have to select only 2 balls from the 10, then there are three scenarios. The first one, either the two balls are green, two green, or one green and another color, or none, no green. So the ways you will choose 2 from 10 will have these three possible scenarios. Either the two balls are green, or one is green and the other is not, or none of them is green. If the two balls are green, that's simple. There are only two green balls. So we are going to choose 2. Or means plus. One is green. So we choose 2. We choose one from the two green balls and another one from the rest of the balls. They have to be another color, be half green. So in that case, only 8 of them are left to choose from. I will choose one more. Or none of them is green. So this 2 is not green, so we are going to just choose 2 from the 8. We have to be careful here, because the green balls are identical in size and of course color. We've exaggerated the counting here, just like something we mentioned there. So we have to make sure that we reduce them, because when the blues, the green change, we will not know. So if I take one green and another color, and another green and another color, and that green is the same green that came from, I won't make the difference. If it's a new one, I won't make the difference. So I should be able to reduce that number of possibility. And that is, in this case, there are 2, so that's 2 factorial, which I'm going to say 2 of them divided by 2. So 2 combination 2 is just 1, plus 2 combination 1, that is 2, times 8 combination 1, that is 8, divided by 2, plus 8 combination 2, that's 8 factorial, or 6 factorial, 2 factorial, and that is, here this is 9, plus, of course 2 cancels 2, 8 plus is 9, and here 8 times 7 times 6 factorial goes out, so I have 8 times 7 divided by 2, 2 factorial is 2, so 2 here, 1, 2 here, and the 4 times 7 is 28, and 28 plus 9 is 37. So it means there are 37 selections of 2 balls that can be made from a bag that contains 10 balls if 2 of them are green and the others are different colors and they are of the same sizes. Thank you, and watch out for the next video. Bye.